Hi, my name is Bob Card. I work for the Wall2Battery group ON Semiconductor, and we're here at APEC 2017. I've got a gentleman here I'm going to show the demo to. So basically, normally you charge through the USB connector of a mobile device. In this case, I'm using a MOFI power station, which is a large 15.4 amp hour cell, just to demonstrate the 8 amps that we're going to be charging this with. Normally you charge through the USB connector. We're going to be charging through our own connector. It's nothing more than an FR4 with copper and gold. We start with a 45 watt TA. ON Semiconductor supplies this primary controller and the secondary controller. It also has a GAN product inside. We're going to put 15 volts, 3 amps out of that travel adapter, a TA. It's going to come to what we call the puck. So up on our GUI here, you can see this is the puck and this is the TA. Right now they're connected. This icon here is for this connector down here on the MOFI. So on this guy, we're going to buck it down to 4.6 volts, 8 amps. Okay. So when we attach to this, we have a switch inside. This is sort of a super switch. He's going to close. He's going to detect the attach. This is going to detect the attach. Right now he's not putting any voltage out. When he recognizes he attaches to this, he puts the voltage out, 5 volts, 4.6 volts. He's going to actually start with a pre-charge, then go to a pre-charge, and then go to the full 8 amps. So I'm going to quickly, and then we have a time plot here, so I'm going to reset it so we can capture that initial attach. So what happens here is he's going to close and put the 8 amps in. So we have magnetics that align the attachment between the puck, which we call the transmitter, and the receiver. So we just drop it, and the magnets align it. The switch closes, and it starts with a small pre-charge current, then it works it up to a higher current, and then it steps up to the full 8 amps. So this is a fuel gauge. The FFG 1040 fuel gauge is delivering this information, the voltage, current. This right here is the blue is the battery voltage. The green is the puck output. And so that'll continue charging. Now we have a huge battery here. We have a 15.4 amp hour cell. We're putting 8 amps into it. That's a little bit more than, that's about 0.6 C rate. So that's nothing to this battery. So it's a very gentle charge. To us, 8 amps on a mobile device is crazy. So what's going to happen, it's going to be about an hour and a half before that actually goes to what we call CV mode. So batteries charge, they start with a low SOC or a low state of charge. They start at they start in what we call constant current mode. And then when you reach the maximum voltage of 4.35 volts on the cell, it's a big no-no to go above that. It can damage the cell, plus trip the protection that's built into the cell. So what happens is this switch, which is the fan 54161, we call him kind of like a super switch. He's not just a dumb switch with low RDS on. He also has voltage and current regulation on the output, voltage and current regulation on the input, reverse current blocking, programmable levels going this way, as well as over a bunch of protection for safety for the battery, over current protection, over voltage protection. So when this reaches 4.35, we programmed this to start regulating. So not let that voltage get above that 4.35. We have a patent pending algorithm that this buck in tandem with this 161, without any protocol, without any digital protocol, will work together and maintain a duty cycle where 85% of the time this guy's in regulation, 15% of the time this guy's in regulation for the entire CV mode. So what that means is, as we know, when any kind of a linear regulator is in regulation, it's going to generate a lot of heat and dissipate a lot of power. So we're moving that heat out of the mobile device. That's one of the key components of this, and to the outside world in this puck.